Let's discuss the Brocards problem in mathematics. Basically, the question is to find integer values of n and m such that n factorial plus 1 is equal to m square, where n factorial is the factorial notation. So if you have an equation n factorial plus 1 equal to m square and both n and m are integers, to find that solution is what we are supposed to do. And at this point, there are only three solutions that are known for this, as we can see here, and only three pairs of n and m are known, and these are called the Brown numbers. As of 2019, these are the only three that has been found, and it has been theorized by certain genius people like Paul Eddowes and so forth, that no other solutions exist except for these three numbers. So let's see if we can find these numbers using a little bit of a our programming capability to look in the search space. As you can see that the final solution that they have given is these numbers 4, 5, 511 and 771. So we can see if we are able to find it. If let's assume that we didn't know those numbers, whether we can find it and how the code will look like. So let's take this piece of code here. So the first one says that n factorial plus 1 is equals, it's a logical condition, equals to m to the power of 2, and this function is what we call as a, right? And so this function is now arrayfied so that you can pass a variety of inputs for both n and m. Remember that when you write in this notation, this function a is going to have a parameter n and parameter m, and when we arrayfy it, then we can supply a whole array of input for the n value and the m value, and we'll go through each of those and give you a result. And the result is now stored in B, and because these results have a certain structure, we do this .io to get it into a 3-column output now, so that n, m, and the output, whether it was actually true or false, would be listed in a 3-column matrix. And then we filter it to find each row in which x2, which is the third column, would be equal to true. So if you run this, you'll search through every combination of 1 and 100 and find out which are the combination of n and m for which this condition is true. So you can see that the answer is 4, 5, 511 and 771, and that's basically what the Wikipedia page says. So we also found the Brown numbers, and these are the solutions, and interestingly, as per the conjecture that Paul Eddowes has suggested, no other solutions exist other than these three pairs in all of the number space. And there is even more extensions of this, where you can go and say for any a that this is true, and there are many varieties of these conjectures. So you can research more on it on the Brocards problem Wikipedia page. And with this code, we were able to check through the entire space and find out the Brown numbers. Thank you.